Okay, it's getting around that time there, folks. Sorry, just trying to get the phone set up here a little bit. Oh, apparently the Hub 1.6 is available. Okay, we're starting the Hub then. Okay. Yes, I know I'm live. I'm trying to actually activate my view here. Okay, there we go. We're working now, please. Maybe. There we go. Remove the volume. There we go. You know, it's a little nimpish in here. I'm gonna keep my jacket on. I was thinking about, taking it off, but excuse me. Did not get a great amount of sleep last night, so okay, let's get this down to where I can see who's following me. And let's go ahead and make it live here. There we go. Okay, so excuse me again. You're probably going to be having a couple yawns throughout this, folks, so I apologize for that. I know that yawning is contagious, and I kind of wish that I could kind of limit that, but it is what it is right at the moment. Okay, so where we left off last night. So last time I had run into quite a bit of problems with Unity. I could not get the camera script to be loaded into the main camera. Uh, I tried different methods. I tried, um, deleting, remaking it. I tried looking into like maybe executive rules that was there. I couldn't find any resource that could really um, push past the wall that was really blocking me on during it. And well, um, I could not figure out for the life of me how to resolve the issue. So I figured maybe it has to do with um, just the fact that I was using an older version of Unity. It shouldn't really matter, but maybe it's one of the bugs that they fixed with the latest version. So I went ahead and downloaded the latest version, as you can see, or at least latest that I know of. Here, let's go ahead and okay. Just look up um, Unity and find out which version they're on currently. Actually, I could probably use the hub now that I learned about now that I think about it. Official releases. Okay, yeah, so they have increased the versions, so they're on 8 now. So, okay. Um, well, I'm gonna hold off on that for now. Um, I mean, I do appreciate the fact that they have like the different versions available for you to download if you wanted to. But I wanted to kind of bring up this one here because I went ahead and I re-downloaded I downloaded the Unity Hub for starters. Okay, I didn't have that last time. Um, the second thing I did was I removed the previous version and downloaded the latest version. And then I proceeded to go through the steps of the tutorials to get back to where I was. Now, I was able to do the step necessary to get the script into the main camera. Um, so I can honestly say that, I mean, if you follow the steps to a T, it should be okay. Um, but here's the problem with that. Okay. Um, if yeah, see, they're advertising their latest version, and I'm gonna skip it for now. Um, so as you can see, I go to the main camera, and there it is. You can see the camera follow script there. Okay, so it does work ish. Um, but here's the thing. If I tried a lot of steps to try to correct the problem that I had last time. I mean, you guys can watch my previous version and part 3, and you could tell, I was trying whatever I could to try to figure out some way of getting the camera follow script to be uploaded into the main camera. And every single time that I tried, I kept on getting the um, the aspect that the mono behavior was not was not in was not in the target. It was giving me basically an error saying uh, it's not associated with mono behavior. I'm like, it's right here. It's right in the script. So where's where's the disconnect? Why is it? Why is this causing a problem? And I couldn't figure out an answer. I looked at all the um, resources on the web to see if anyone could figure out, what went wrong. Everybody kept on talking, oh, you didn't have mono behavior, or you messed up, the file name didn't match with the class name. And I'm like, okay, granted, initially when I did create the file, I didn't have the correct name on it. Okay, but here's the thing. I did fix that later. Matter of fact, I even deleted the file and made a new one with the correct name, and it still wouldn't work. There's a problem there. Um, I sent this off to the guy that does the QA testing for this in Unity. Um, I'm really trying not to be a problem with them, but I mean, if I'm finding weaknesses in their IDE, then matter of fact, I wonder. Last time I clicked on this link, it opened up a window to a 404 website. So I'm wondering if they actually fixed it in the latest version. Yeah, let's use Firefox. Taking its sweet time. Um, don't need the bookmarks for now. So while that's loading up, um, so needless to say, I was able to get it working with this latest version. Now here's the thing. I'm half inclined on deleting all the work that I did to get back to this point, which I mean, wasn't a whole lot. And if I followed the exact same steps that I did in for the previous version, will I encounter the same problems? Um, uh, I don't know that. I don't know the answer to that. And I'm wanting to try to make sure that I get to a point of, um, I want to record my steps so that if Unity does watch this, then they understand, what steps did I take, um, and um, they would be able to figure out on their end how to correct said mistakes. I don't have access to their code. I don't have access to their backend processes. I mean, this isn't on GitHub to my knowledge, so I mean, there's no way for me to um, uh, there's no way to my knowledge to modify their code or to look at their code to see if maybe I can help out in some way or another. I, I doubt that I can. I mean, there's a lot of people that kind of work on these kind of projects. They've seen the code. Um, I've had projects before where I've had to look at millions of lines of code um, through SourceForge before, and it's a daunting task. So I'm one that uh, while you know I wouldn't mind trying to take up that flag that um, charge in some fashion or another. Um, I don't know if I don't have the permissions or anything along those lines. So um, that's just gonna have to be on their end. So um, excuse me. Okay. Boy, I'm really lagging out here on my OBS. Is everything going okay on the stream? I don't know. Doesn't really look like it. Oh no, stream's looking good. Okay. It was my OBS is really wigging out on me though. Okay. Um. So yeah. Aha! They did fix this. Okay. Okay. I wonder. Did they? Did they change the? Did they change? Well, hmm. Okay. They're referencing the a file on the computer itself. Okay. They're not actually going to a offsite. As you can see here, it's referencing an HTML file that's on the drive. So they basically allowed the API to be downloaded onto the documentation to be downloaded. Um, this can be kind of problematic in the sense that um, if there's any changes, then you don't get to see any like updates for it unless you download said updates. Um, but it gives the user more control over what they see, and it gives them um, in a sense a book. I mean, something that they can kind of use um, on their own time, kind of aspect. So there's some pluses and minuses to both sides of it, kind of thing. Um, so I mean, uh, if you're wanting to kind of do this offline, then you have the resource here available. You know, it's showing you the link for it right here. Whereas in part three, it was giving me the 404, which um, was it a was it a bad address that from the editor trying to access um, uh, a file, the documentation on your hard drive somewhere and couldn't find it? Or was it actually pointed to the website, the Unity website, and it wasn't finding the address there? I don't really know. Uh, I don't know what address that, um, I don't know what address this was kind of pointing to um, for the previous version. So, um, here it just says open reference for mono behavior. You know, um, if you were, um, if you're like constantly online kind of thing, I would figure that they'd want to have that be pointed to uh, their website so that it will constantly be updated and um, if there's any kind of changes that they needed to make for that particular version or something like that, then they can make said changes. But but then again, based off of what I can see right here, they're really um, uh, they're only adding, uh, the different like behaviors and modules and methods and properties and so on and so forth, um, for that specific version. Uh, so like for example, if there was like a function like say on on enable wasn't actually implemented with uh, in the previous version, but now is, then um, you know, on their website, would would they have the different versions of mono behavior per version, or would they have the latest and greatest? It's an interesting distinction. So, um, but it looks like they're trying to keep the documentation uh, up to date per version. So what you download is that version's up to date documentation. So that's good. I you know, like I said, there's some pluses and minuses for both sides, but I mean at least you're getting the API that is focused for that particular version and not given some kind of reference to something that you're not 100% sure on, kind of thing, like, or it's not pointing to an updated version that has methods or functions or whatnot that is not actually implemented in the version that you have. Um, so yeah. All right. Uh, okay. Let's see. Wow, I've already talked 20 minutes about this. Okay. So, on one hand, I want to try to redo what I did before and see if I can still cause the crash with this particular version. Um, although, here's what I'm going to do. I'm going to get through the rest of the tutorial uh, for this particular version. Then when I'm done, I'm going to download the latest version, and I'm going to try to do the steps that I did prior, in hopes that they did look at what I was, in the hopes that the engineers with Unity has actually seen what I'm actually doing, and maybe they did do some updates. I don't really know. I'm I'm just throwing that out there. I mean, uh, they're always welcome to see my steps on this and um, use that as a idea of uh, you know uh, I mean they have their own QA staff, uh, but obviously if they see other videos of the tutorials and usage of Unity, then that helps them make Unity better. So, and I'm perfectly fine with that. If they need to um, see my usage to figure out how someone uh, might change their, uh, if if my steps is something that they didn't think of prior, and it leads to a problem with the IDE that they need to fix, then all the better. So, uh, so they are most welcome to, um, you know, to do that. I have no problem with that whatsoever. So, I mean, hell, I'm using their product. So, um, I mean, it would be nice to kind of be in contact with them a little bit more about this, but they're busy. I can understand that. So, okay. Um, I need to get um, to their YouTube channel, so that's actually let's go ahead with my Google Chrome. I have that linked to my particular profile, so there we go. Okay, Unity survival game tutorial. Okay, now I was on cameras. So I believe this is the one. Oh, it's muted.
Are pre-written.
Whoa, loud. Sorry
so
about that,
the
folks.
main camera is the camera that we're viewing our game at. If I zoom out right now, you can see that the main camera is sitting behind the character. And what we want to do is to set that up slightly differently. Currently, by default, when you make a new camera in Unity, you're making a perspective 3D camera. We want to make an isometric view, and because of that, we're going to use orthographic cameras. So the first thing we're going to do is to set up where the camera is positioned. We're going to select our main camera in the hierarchy, and in the transform component, we're going to set the position to 1.
Okay, I'm going to skip ahead here, folks, because I've already kind of gone through all these steps as it is anyway.
30.
So
Moving fixed update. So we're going to use fixed update to move the camera, and we need a target position for this camera to try and reach. Target position is going to be the position of the target plus this offset. So we're trying to find a place for this camera to be up above the level, and that's the position of the player plus this offset that we've stored. And now we need to actually
skip
naturally,
forward a little bit
since
more.
we don't want it to do it 50 times a second.
There we go.
What we do is in the Unity editor, select camera follow and drag and drop this onto main camera. So from the project panel, drop it onto main camera.
Okay, so this is pretty much where I was having an issue with the previous version. That whole drag and drop was not working whatsoever. Now, that was because of the fact that when I named the file initially, I didn't name it camera follow. So even though I renamed it, I deleted it, I did multiple steps in the last one, so I'm not going to repeat all that. But this is where I left off. I stopped where I was, so that I wouldn't. So I'd be able to kind of continue where I left off in the last version. So there wouldn't be any kind of like confusion, or people would be like, hey Jim, why didn't you do, why are you suddenly on step 4 of the tutorial? I didn't want to do that to anyone. So, yeah. I think that, okay, we can move on.
When you've done that and select main camera in the hierarchy, so you should see this camera follow script that I have in the lower right. you'll see that the public variables target and smoothing appear as things that we can assign to in the interface. So target is looking for something called a transform, and smoothing is a number that we can change to whatever we want. Then what we're going to do is to assign the target. The target, of course, is the player, so we just drag and drop player onto the target variable.
Grab the player from the hierarchy and not the scene view. Clicking and dragging the player in the scene view is just going to move the player.
Yep.
Okay.
So one thing you'll notice as well is if you go to click, then drag, you lose the context of the main camera. So select the main camera, then drag and drop player on there. So basically all that's doing is it's finding the game object reference, and then it's finding the exact thing that it wants. It wants to find the transform. Then we're going to save, and then finally we're going to save our player as a prefab. So like I said before, when we introduced the environment was saved as a prefab because we've already assigned a bunch of components to it. So if you've got something set up the way you want it and you want to save it into the project, so we might want to use the player in other levels of the game, so we save it as a prefab. And the way that you can do that is just to drag it anywhere into the project. We happen to have a prefabs folder, but you don't need to drag it into there, but we'd like you to. So player, drag and drop from the hierarchy and drop it into the prefabs folder in the project.
If you turn it into a prefab, it's an asset, it's a hard drive file. You can save, export it, reuse it all over the place, and then, yeah, so there's more benefits to turning things into prefabs.
Okay. So their drag and drop into the prefabs folder, it was an automatic assignment. There wasn't any kind of pop-up that they had on there. So again, they're giving me a choice that their outdated video was not showing me any kind of details on. I dragged the player. So would you like to create a new original prefab or a variant of this prefab? I'm not changing any. I'm not. There's no player inside the prefabs to be changing. So, and I've made updates to the player in the hierarchy. So am I needing to keep so I'm kind of confused by that question, really. Okay, so by making changes, I've modified their prefab of the player that they gave me. Well, here, let me cancel out of this. Okay, so you know, in their characters, I used player to drag up there into the hierarchy, so that I can make changes to it. This was their prefab player model in the characters, but it's not in the prefabs folder. There's no player in the prefabs. So when I do this drag and drop, is it a new original or is it a variant? The fact that I made modifications to this particular prefab already makes it a variant. So I'm not using the original player prefab that I moved up into a hierarchy itself. So what are they referring to on this? I don't know. I'm not quite sure what they're kind of asking here per se. Um, I mean, are they for the original prefab? Are they referencing the player prefab that I originally dragged into the hierarchy? Um, and so therefore, seeing that I made changes to it, is that the prefab variant? I don't really know. I don't really know what they're kind of asking on this. I'm gonna go with prefab variant because it's the only thing that I can think of as what they're trying to go with on this. Seeing that I made changes to their prefab originally, I'm gonna assume that it's already a variant, and therefore I'm making a variation of the prefab to save in the prefab folder. But their question is confusing in my opinion. Okay, here's another problem. The fact that I clicked on player variant here is not the same as what they have there. Hmm. Okay. I'm not 100% sure on this. I don't know if I might have done the incorrect method here, so I'm going to go ahead and delete this for the time being. That's fine. I'm going to go ahead and drag this down here again. Interesting. It didn't give me the option before. It's okay, now it's not even giving me the option of the variant. Um, what's going on here, guys? Why are you giving me these pop-up windows for something that only happens once? You know, what's going on here? Okay, um, so this is now following what that has right there. So and I can't seem to bring back that player variant aspect of this. So I guess I'm on the right track again. Ah, man. Well, it's for them it's a work in progress. So I can't, you know, um, I can't really, um, I can't hammer them too hard on this. Okay, just saying that out loud. I mean, all these applications that are out there nowadays, you know, um, you know, operating systems like Windows and Linux and um, uh, OS X, kind of thing. It's uh, Visual Studio. Um, they've all started somewhere, okay, and obviously they're gonna have some problems along the way. So um, it it's just odd for me to see, the window pop up for giving me a player variant, and it doesn't give me that option again. It just causes confusion for me. It's like, mm, why are you having this pop up once and not give it to me again for something that I do at the same, I'm doing the exact same steps, um, and I'm not getting the pop up again. It's inconsistent. So, uh, well, I gotta move on.
So I want you to save your scene right now and press play, and you should have a little character that runs around, and you can move the camera, should be tracking him. And we'll show you what that looks like right now. So you should be seeing this. Camera's now tracking around, and we can rotate like this.
Okay, let's go ahead and give that a try. Now, as I stated in the um, previous videos, the animation for the movement um, isn't automatic because it does the idle animation first, and it doesn't allow for the movement um, until after the idle animation is complete. So, um, like I can move around right now, and yeah. So here's the idle animation. Oh, movement, idle animation, and now I'm sliding along the floor like I'm doing nothing. Idle animation right there, and that, and eventually it's gonna go to walk in again. There it goes. So, um, I'm kind of curious actually. Let's.
You can move the camera, should be tracking him. And we'll show you what that looks like right now. So you should be seeing this. Camera's now tracking around, and we can rotate like this.
Okay.
And the way that you can do that is just to drag it anywhere into the project.
If you turn to a prefab, it's an asset into prefabs.
So I want you to save your scene right now and press play, and you should have a little character that runs around, and you can move the camera, should be tracking him. And we'll show you what that looks like right now. So you should be seeing this. Camera's now tracking around.
Okay. They have almost instantaneous movement on that,
Like this.
which um, doesn't coincide with what I have here. Um, so I'm not quite sure I mean, I follow their animation steps to a T, um, so yeah, okay, well, gotta move on. So,
The next phase we're going to go into is to create our first enemy. So we need our enemies in the game to damage the player. We need them to follow the player. But in this particular one, we're just going to create the first enemy and make him kind of follow you around. So let's dive straight into that. As before with the player, in the models folder, in characters, you will find there are some models. One of those models is this lovingly created Zom Bunny, which looks something like this. And what we're going to do with that is to place him directly into the scene and then start working with him in a similar way that we did with the player. So as usual, I'm just going to quickly hit save, just so I don't lose any work if we get a crash. And then I'm going to drag my scene view around. And this bit really doesn't matter where we place him because we're going to spawn him later on. But I'm going to use dragging from the project window, and you can see that it snaps to the environment or whatever I happen to place him onto. I'm just going to drop him near the player, somewhere like that. Then when we shoot this bunny, we're going to have stuffing kind of fly out of him. So we've created for you a particle system to do just that. In the prefabs folder, you will find a hit particles prefab. So like we said before, prefab's a way of storing something that you've already set up, and we did exactly the same thing. We've created this hit particles. And what we need to do is apply this to the Zom Bunny. So in Unity, all game objects that you put in can have a hierarchy. So the Zom Bunny has a child object, which is its mesh, its kind of outline, but it also has a parent, and we want to drag drop this particle system on so that it's attached to the parent. So what I'm going to do is select my Zom Bunny, and I'm going to drag and drop hit particles onto the parent Zom Bunny, so that when we expand it, we've got Zom Bunny, the actual object itself, and hit particles.
okay.
And basically all this is doing, if I select my hit particles now, is creating this little puff of stuffing. So I can see that because I've got that game object selected, the scene view shows me the particle effect overlay, and you can see it's creating a puff of fluff that's coming out of him. This particle system, we didn't want to get bogged down too much with these various settings, but we're basically using a texture which is applied to this to just fire out a little emission of those. Again, we want to detect whether this is something that we can shoot at. So similar to how we detected whether we can turn to face a particular way by isolating the floor onto a floor layer, this Zom Bunny is going to be on a shootable layer. So with the Zom Bunny parent selected, so make sure you reselect the parent, go to layer at the top of the inspector and choose shootable. Okay, so set that to shootable, and then it's going to ask you if you would like to change the children. So basically all this is saying is, do you want them all to be on the same layer? The child objects say yes, change the children.
A quick note, the environment that you all dragged into the scene at the start is also on the shootable layer, so that means that when we later give the player a working gun, you can hit the environment as well.
Okay, here's when they told me to change the children. That's all well and fine. If somebody, somebody is a child of somebody, right? But it also says that hit particles is also a child of somebody. So it's just basically told me that hit particles is shootable. Why? You don't want hit particles to be shootable. Because that has the potential, I mean, that doesn't really make any sense. I mean, you don't want the hit particles to be shootable because then your shots would be blocked by the particles themselves. Unless there's something that you can kind of modify with hit particles so you can kind of ignore that. But why would you want to have it on that shootable layer. That doesn't really make any sense to me. I don't understand why that would be a thing. Why you'd want that. So, but maybe they'll address it later. So let's continue on.
We've done that, and then we basically want to set up the Zombunny in a similar way to the player. So we want him to have physics, we want him to have a physical presence in the world. So we're going to do some of the similar things that we did before. The first one of those I'm going to do is to add a rigid body component. So just to give you a different way of doing things, we previously used the menu, but you'll notice that this is actually a search field. So I'm just going to type in rig, and I go straight to rigid body. I can hit return to add that. I'm just going to make that expanded so that I can apply some settings. Again, drag and angular drag should be set to infinity. So I'm going to type in INF, hit return, and it should change to capitalized infinity. And the constraints are exactly the same. We want them to be able to rotate only in the y-axis. We want them to only be moving in x and z, and frozen position y. So your constraints should look like this. Freeze position y, freeze rotation x and z.
Okay.
In order to actually give this physics object a boundary, we're going to put in a capsule collider, so the outline of its physical shape. So I'm hitting add component one more time, and then I'm going to type in cap for capsule collider, and the settings for it are center value of y 0.8 and a height of 1.5. So it should look like this.
Okay.
We need this character to attack the player. So this bit's going to be slightly different to how the player was set up. So the capsule collider is there to give this character a physical presence. But what we want to do is to give him the ability to detect the player. So we're going to use one more collider to do that. And we're going to use a trigger collider for this purpose. So we're going to add component one more time. And we're going to say SPH sphere collider. Hit return. You can also go to, of course, add component physics sphere collider. But that's just a short way of doing that. So a trigger is something that doesn't have a physical presence. It's a collider, which means you can check when something's intersecting it, but it doesn't have a physical presence. So we can just walk straight through this thing. So we check the is trigger box. And then if we just have a look back at our bunny very briefly in the same window, you can see that by default it's set at the origin of this, which is at its feet. So we're going to set the center Y to 0.8 and the radius also, for simplicity, to 0.8. So what you'll see is that if I just expand my capsule collider again, it's slightly further out than the capsule collider is. The
Okay.
reason being that we want to detect the player within the bunny's reach kind of thing. So we want it to bump into stuff, but we want its reach to be able to harm the player. So we make that sphere collider slightly bigger. We make it a trigger so that it's not actually going to bump into anything. That's how we're going to detect the player.
Yeah, so again, with triggers, the actual interactions within the scene is not what we use a trigger for. More importantly, a trigger, when anything collides with a trigger or goes into a trigger, a function is called if you have a script attached that says, hey, something touched that trigger, right? And that's when we write our individualized code that'll be like, okay, something touched that trigger, right? So its interactions in the scene view are not what we're interested in. We're actually interested in the behind-the-scenes interaction we get to write with our own code.
And finally, the last thing we're going to do to complete the Zombunny is just to add an audio source. So I'm going to type in audio. I'm going to scroll down. I can use my arrow keys in this add component menu. And I'm going to use return to choose audio source. So this thing is just to allow him to make a sound when he gets hurt. And we're going to make that the default sound clip as well. So as before, using circle select, I can just click and choose Zombunny hurt. It's the very bottom one from the list. I can double click it to assign and close the window. As before, we don't want it to make the sound, so we're going to uncheck play on awake.
Okay. Hold on a second. They were kind of stepping away on that a little bit. Okay. The audio clip menu disappeared on me. There it is. Okay, so he was right. It was the last one on there, but it was still one of those aspects where it's like, you know, which one of the two. But okay. So there's that. I gotta move back. No, I gotta rewind a little bit.
I can double click it to assign and close the window. As before, we don't want it to make the sound, so we're going to uncheck play on awake. We obviously don't want that to loop or anything, so we're going to leave that there. Next, we need to make the guy actually follow the player. So in Unity, there's a system called NavMesh. So in Unity, window navigation is what you need. Window navigation. That should automatically dock itself next to the inspector. If it doesn't, that's a great place to put it. So drag and drop that tab.
Okay, hold on a second.
Follow the player. So in Unity, there's a system called NavMesh. So in Unity, window navigation is what you need.
Window navigation. Okay. There's nothing here. Okay, so here's the navigation component.
Window navigation. That should automatically dock itself next to the inspector. If it doesn't, that's a great place to put it. So drag and drop that tab next to the inspector on the right of.
Okay. Definitely not the component aspect of it. They're actually wanting to kind of have a different navigation up here next to the inspector. Problem is that I don't know where navigation is under. Okay. He was talking about the pathing of the of the AI creatures. So I'm gonna have to assume that this is the navigation that they're referring to. Again, different systems, Windows versus Apple. So okay, I'm hoping that this is correct.
Your interface. We're going to reselect the Zombunny and go back to the inspector. The navigation panel is there for us to set up our level. We're going to set up our Zombunny first, and then we're going to go back and set up the level. So with our Zombunny selected, I'm just going to close some of these by collapsing them up, give us more space to look at.
Okay.
I'm going to add something called a NavMesh agent. So like I said, there's a system called NavMesh, which is used for simple AI in Unity. And basically what it means is you can do a process called baking, which is to specify which parts of the level are navigable. And then you have something called an agent, which is something that's going to traverse that or move over that environment. So the Zombunny is something that's going to do that. So we are going to give it a NavMesh agent component.
Okay.
You can see that it has an outline here, similar to a collider. And we're going to set a more appropriate radius than the default of 0.3. So 0.3 in radius. We're going to set the speed to 3 by default and stopping distance to 1.3. And we're going to set the height, which is slightly lower down, to 1.1. So
Okay, hold on a second. He went through. He went through a couple of stats there that I wasn't catching. So
0.3 in radius. We're going to set the speed to 3 by default and stopping distance to 1.3.
Okay.
And we're going to set the height, which is slightly lower down, to 1.1. So because it's easier to see these settings on the PowerPoint, I'm just going to switch over to that. So we've added an NavMesh component. The radius is 0.3, speed is 3, Stopping distance is 1.3, and height, a few properties down, is 1.1. It should look like what we have in Unity.
If you recall, for the player, we're moving the player using physics, right? We're not doing that with the bunnies themselves. The nav mesh agent is actually what is moving. So just keep that in mind. We're not actually going to be using forces with the bunnies. Instead, the nav mesh agent is going to pick and follow the target automatically while also avoiding obstacles and things like that. And that's what Will meant when he was talking about AI. It's this AI pathfinding.
What I wanted to point out as well is, and you guys don't need to do this at all, so if you could just watch for a second, the environment is already prefabbed. We put colliders onto everything, so you can see that the player can bump into all of these objects. We used primitive colliders for performance reasons to make it all work nice and neatly. What you should also note about that is that there's a checkbox up at the top here called static. That's checked, and that means that navigation static is also checked. So what that means is that all of the things that we've specified in here as being a navigable space are going to be included when we bake the nav mesh, when we create this navigable area. So what I want you guys to do now is to go to that navigation window again, and we're going to switch over to the bake tab, so the middle one of the three.
Okay.
And then we have some settings that we're going to put in there.
The radius of the nav mesh is approximately how near to a wall an agent can move. So we're going to have multiple types of enemy in this. So we've got some zombunnies, some zombears, and some elephants. Now, elephants are a lot bigger, so we need to compromise with the radius of the nav mesh. Normally, you'd want to have nav mesh agents and nav meshes with the same radius. But since we've got different size agents, we're going to compromise and make the radius for it
0.75.
Likewise, this height is a compromise. We have zombunnies, which we made 1.1 in height. The elephants are going to be a lot bigger, but we're going to make our height a compromise between the two. We're going to give it 1.2. But normally, if you've got one type of agent and they're all the same, give the radius same as the nav mesh agent and the height the same as the nav mesh agent.
Okay.
So the next thing we're going to change is the step height. So your nav mesh agent can go up steps, and because our floor is uneven, it's made up of floorboards that are sort of sticking up a little bit like that, we need the nav mesh agents to not go like, oh, I can't get over that floorboard, I better go around it. So we need a very small step height to make sure that it can get up over those bumps.
Then we're expanding the advanced area, and we're setting the width inaccuracy to just 1%. So drag that width inaccuracy down to 1.
So
Okay. So it's not showing it here. Again, old video. But it is referencing the fact that, step height conflicts with max slope. This makes some slopes unwalkable. Consider decreasing max slope to below 14.0 degrees or increase step height to above 0.38. So they're factoring in, how much, height you can actually, how much height they can actually do. And they're saying, well, based off of, all the other factors of what has already been kind of designed with, gravity and all that kind of aspect, it's basically saying that the AI wouldn't be able to traverse any object that had a slope of 45 degrees, with the step height. So they're suggesting, hey, reduce down the slope to 14, like so, or increase the step height to 0.38. So it allows for the for any kind of it allows basically the agents to be able to traverse an angle of 45 degrees. So if you actually have, if the player is able to actually get on top of one of the uh, collision objects, for example, um, then the agents themselves might not be able to follow him. So interesting. So uh, I'll go here now. Um, they opened up the advanced and they changed the width inaccuracy to 1. Um, there's no width inaccuracy here. Okay. Is that somewhere else? Um, does anyone, if anyone's watching, do you know where the width inaccuracy is? Because I'm not seeing it right at the moment. And obviously it's not here and under advanced. Um, yeah, okay. Well, okay. I gotta move on. I don't know. Here, let me see, let me rewind, see if I can maybe interpret what they're saying and see if I can maybe figure out um, where I can find the width inaccuracy. So,
We need a very small step height to make sure that it can get up over those bumps.
Then we're expanding the advanced area and we're setting the width inaccuracy to just 1%. So drag that width inaccuracy down to 1.
So the width inaccuracy affects how carefully the nav mesh is baked. A nav mesh can be baked very quickly if you give it high inaccuracies, and it'll look quite angular and it'll be quite approximate to your environment. But we want it to be a very accurate nav mesh. So this is going to take a little while to bake, but we'll end up with a very nice nav mesh afterwards.
So once that's done,
okay. Uh, that didn't really give me anything. Uh, okay, most that I can think of is maybe they put it under the manual voxel size. Probably. Um, but I don't know how voxel translates into what they have with the width and height inaccuracy. So once again, I'm hit with the fact that their tutorial's old. Um, okay, so I'm gonna have to assume that maybe their manual voxel size is representing um, the width and height inaccuracy. I mean, they have the min region area already covered. They have the
and it'll be quite
um,
approximate to
height
your
mesh
environment. But
there.
we want it to be
So the only other factor that I can see that they're they're doing is the manual voxel size. That's the only assumption that I can kind of glean from this, you know. So uh, now this was set to 16.6 with 10 percentage. Um, I wonder if that has, you know, almost a like a um, like are they adding those two together to get the 0.25 or something along those lines? Like for example, if I change this to say zero point 0.1, is that a representation of what they eventually
can get
move
up to
this
those values.
towards?
Then we're expanding the advanced area and we're setting the width inaccuracy to just 1%. So drag that width inaccuracy down to 1.
So the width inaccuracy affects how carefully the nav mesh is baked. A nav mesh can be baked very quickly if you give it high inaccuracies, and it'll look quite angular and it'll be quite approximate to your environment. But we want it to be a very accurate nav mesh. So this is going to take a little while to bake, but we'll end up with a very nice nav mesh afterwards.
So once that's done,
Okay. Um, so here's what is kind of throwing me off by it here. They're saying that it's highly accurate.
Be baked very quickly if you give it high inaccuracies, and it'll look quite angular and it'll be quite approximate to your environment. But we want it to be a very accurate nav mesh. So this is going to take a little while to bake, but we'll end up with a very nice nav mesh afterwards.
so
Okay. So seeing that they're talking about, you know, trying to make it highly accurate, um, yeah, voxel size controls how accurately the navigation mesh is generated from the level geometry. Good voxel size is 2 to 4 voxels per agent radius. By making the voxel size smaller will increase build time. Um, so is the higher the amount better overall for voxels per agent? Or do I have to do, um, or do I need to kind of go more with a lower voxels uh, to be good? I'm gonna have to. I'm thinking. Um, you know what? Let me look this up real quick. I wanna make sure absolutely on this before I continue on. So, um, okay. A voxel represents a value on a regular grid in three-dimensional space. A series of voxels are stacked with a single voxel shaded. Okay. So, this is um, this is basically like like this is kind of showing here. It's a cube within like multiple cubes uh, encompassing, some kind of object of some sort or not. Okay. Now, uh, so the the higher the number, or the higher the voxel size, the lower the amount of voxels per agent. Now, that means that the box here is actually getting larger in that case, meaning that the agent is only has a few of the voxels contained within it. So, um, but if I went to a 0.1 with 7.5, then that means that there's more boxes within the agent in question, and therefore um, um, it's like if you're talking like gaming terms kind of thing, it's kind of like a hitboxes kind of aspect. Um, One of the main problems that a lot of games have is you think you punch someone or you shot at someone or something like that, and you can almost see the bullet, like, you know, or you see the fist or something like that go through um, the animation of the character that you're trying to like hit or punch or whatever, and it goes through the um, the image, but there's no actual collision with it. Okay, that hitbox is small, so um, it doesn't register that you actually did any kind of hit to it. Okay, same. So based off of what I'm seeing here, the voxels are kind of like that. Um, Kind of like that. It's um, the more voxels that you can put in encompassing the agent, then it's a little bit easier to actually hit, you know, uh, the target, because there's boxes in those locations of said agent, the zombie in this case, um, so that when you do shoot it, there's a voxel there that might intercept it more, with the fact that there's multiple, there's 7.5 voxels per agent. So more boxes means more opportunities to actually hit the agent in question. At least that's how I'm interpreting this right at this moment in time. If I'm completely off, please let me know, because you know, their tutorial is not covering this whatsoever. So this is the best that I can kind of come up with on this. Um, if I am correct in this, please let me know as well, so that I can go check mark. I got it. We can move on, or at least um, I won't be second guessing myself. But I believe that's the case. Um, Based off of everything that I'm reading here, based off of what I'm reading here. Um, so it's the most that I can kind of think of. So we're going to move on.
So once that's done, you are hitting bake at the bottom of the window. And what you'll see in the scene view, once it's completed that process, is that you'll see a blue overlay on the entire level. So you'll get a progress bar at the bottom. It says exporting tiles like this. Once it's done, that process, you will see an overlay in the scene view as long as you are on the navigation window. And it should look something like this.
So what's
Okay.
happening here, by the way, is agents in pathfinding and all that will work with complex meshes. However, it's incredibly inefficient, right? And you're going to have all sorts of issues if there's bumps and cracks and things like that. Basically saying that while you can traverse these unusually sized and shaped meshes, it's really not worth it, right? You generally want your movement to be smooth, and you don't want it to be that inefficient. When we bake in NavMesh, what it's doing is it's finding all of the static meshes in our scene, things that are marked as navigationally static, and saying, these aren't going to move, these are going to be things that we can walk on, and it's going to calculate a very simple, flat mesh and go, it's not exact, but it's close enough and no one will ever know, so it's much more efficient, and it actually makes it much more accurate as far as actually moving around how you would expect things to move around. So that's what we're doing. We're actually, on the fly, Unity is generating a new mesh, which is just a flat plane, possibly with a slope to it or whatever, but it's very simplified, and it makes the actual AI process of navigating very simple.
Just to make this very clear, these things in our scene are marked as static. So if we wanted to move our blocks at some point, we'd change the design of the game, we would move them and we would rebake the nav mesh to recalculate that traversable area.
Okay, so so let me try to break down what they're trying to state on this. So basically, all this blue area that it's referring that you can see on here is basically this, the Zombunny can actually traverse these kind of locations a little bit more to kind of be able to kind of go around. It's looking at these the collision objects here and going, well, I'm not going to be able to go anywhere near these, so I'm just going to kind of move around them, by taking another path on, in the blue area. Now, here's where I'm not quite sure what's going on here. See, there's some areas that don't have any kind of blue whatsoever, and based off of what I'm seeing, there's nothing that should be interfering um, with the agent on this. I mean, I just look here, and on this particular spot, and there doesn't seem to be like any collision objects there that should be causing such a unmovable path on this. So could this actually be a problem with the voxel size? Could this be a problem with the step height and, slope maybe? I don't really know. I'm thinking that it has something to do with the step height and slope. But again, I'm not 100% sure on that. I'm saying that it's max slope and step height because there's no objects here, that is blocking the path. So, oh boy. So here's what here's why it matters. The fact that I'm kind of worried about these spots here. Okay, um, like what happens if what's going on? Oh, okay. I was about to say, I was like, what happened to my cursor? Um, so let's take a look at this over here, for example. You know, um, so there's a fairly wide spot here. So let me kind of move over there real quick. All right. So if I was to stand right here, technically, because it's an allowable location, then um, uh, yeah, I'll try to actually move him if I can. Ooh, I didn't want to actually. Okay, so for example, if he was like right there, for example, I'm just throwing that out there. I'm gonna kind of undo the positioning that I made on him. Um, if he was there, then based off of what I'm seeing here with the baking of the mesh, and the blue being the path that the zombie can take, it means that the area that is not covered in blue is areas that the zombie would not enter, or would kind of avoid, move around, so on and so forth. So if if I was to like run the game like right now, or um, if I actually had the AI kind of working right at the moment, they would basically get to the edge of that, and they want to be able to enter that particular zone based off of what I'm seeing right at this moment in time. So that's why I'm kind of like, I'm looking at their video here, and most of their areas are pretty much covered. I'm not seeing multiple different spots in their map that is causing these kind of um, open holes, I guess you might say, for it. Their objects are causing, um, that they have they have objects that have some kind of collision to them, but there's no collision to these particular locations here. So the most that I can think of is it could be a step height, for example. Like this this particular portion right here could be at a height that is, you know, uh, has that um, 45 degrees or higher kind of slope to them, even though it's a fairly short distance kind of aspect. It's still one of those things that it's like, well, um, the the AI is trying to get to that particular area, but it can't. Why? Good question. Could be agent radius, could be agent height, could be max slope, could be step height, could be the voxel size itself. I'm not sure. I'm looking at the Unity tutorial here, and it's not matching up completely. But again, it's already been something that I've addressed um, previously. So I don't want to. I've already hit, um, I'm basically beating a dead horse at this point with that. So um, problem is that I'm not quite sure how to go about it correcting this difference between the two right at this moment in time. I don't know what's necessary. Why 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 are there more gaps under what I have versus what they're showing? I don't know if like maybe the voxel is a problem. You know, maybe I need to have it, a little bit more like, or the voxel is a little bit less. So maybe if I do bake on that, say, um, there's there's not as many gaps. I mean, there's a huge one right there, but um, maybe if I do point 0.2, again, there's different. Yeah, there's some places that are allowing more movement path than before, but there's been shifts in what can be done and what can't be done. So okay, this one isn't that bad now. I mean, there are still some gaps in there, but let's see. Okay. So as I continue to increase the voxel size and lower down the amount per agent, um, I'm not seeing as many um, locations with empty, or there's not gaps in the blue as much anymore. Um, so I'm not 100% sure um, again what the voxel size is, you know. Um, did they reduce down um, the width and accuracy to allow for, more of a coverage? I'm not sure, but I gotta move on, so.
Okay, so we need this character to run around and chase the player, so we're going to apply animation to this. What we want to do is to select the animation folder in the project panel. I'm going to click the Create button, and I'm going to choose Animator Controller. So select the animation folder, choose Create Animator Controller. This one is going to be Enemy AC. AC short for animator controller, and then we're going to assign this to our Zombunny. So the Zombunny, if we drag and drop that asset onto it, it will assign it for us. But just to be clear, what we're actually doing is assigning this to the controller property of the animator. So either drag and drop to that component, or simply drag and drop straight onto that object to automatically assign it for you. So when you select the Zombunny, you should have animator enemy AC as the asset. So that is a animator controller, a state machine. So I'm going to double click enemy AC to open it in the animator window. We should have an empty new state machine to add animations to, just like we did with the player. As before with the player, the animation for the Zombunny is stored within its model. So I'm going to expand the model and go to the characters folder in the project. So in the project panel, open up models and select character, and then expand the Zombunny, and you will see that and its animations. The Zombunny has move, idle, and death, and they are clips that are on a particular point in the timeline. You can see as I go between these clips, they're all in a different part of the timeline, as you can see from here. The way that we can do that when you bring in an FBX model that you've animated is you can just create new clips, and you can tell it what frame range you animated them on, and Unity will import those for you as different clips. And just like the player, they appear underneath that in the hierarchy. So you have death, idle, move. Just as before, I'm going to drag them in. I want the default state to be moving. So I'm going to drag that one in first because that gets made the default. Default signified by orange. Then I'm going to drag in the other two, idle and death even. I'm going to put death next to the any state, and I'm going to put idle and move together. Again, the position of these is kind of irrelevant, but I like to have things nice and neat. Once those are in there, we've positioned them nicely, we're going to create parameters for them. So making sure that move is the default, so set as default with right click if you haven't already. We're going to create parameters. We have just two parameters for this one, and as before, we're going to click the plus icon and we're going to select the type of parameter that we want. So we want a trigger parameter called player dead. These enemy characters are going to walk, they're going to have their moving animation until the player dies, and then they're going to go into their idle animation. Then we're going to create another trigger which says that they themselves are dead, which is just called dead. So two trigger parameters, player dead so that they can go to idle when you get killed, and dead themselves so that they can animate into their death animation. Then of course we need to actually control the logic of this state machine. We want our move to transition to idle. So I'm going to right click, make transition, and again I get the transition handle. I'm going to click on idle to assign it. I will select the transition by clicking on it. Once that transition is highlighted in blue, I should have my list of transitions. So in order to go from move to idle, the condition is that the player is dead. Then very simply, in order to go from the any state, I will make a transition, click on death, select that transition. The condition for that is that the dead trigger has occurred. So if I just scrub through, you can see we go from moving into death.
You've also noticed that you can't go from idle back to move,
Yep.
because at that point the player's dead.
So we have no need to create a transition back. These state machines don't work by themselves. The connection between the state machine, the animator, and the actual functionality is that the scripting needs to tell those parameters what their value is. So we need a script to say that the animator set trigger, player dead, will actually happen. Otherwise, the animator does nothing by itself. In the scripts folder in your project, you will see a folder called enemy. So go to scripts folder and open the folder enemy. And in that you'll see a folder called enemy movement. We're going to drag and drop that onto Zombunny in the hierarchy.
Okay. Okay, so took care of all the layers, took care of the parameters. So
A folder called enemy.
he was talking about scripts. That's right. Enemy. Okay.
So go to scripts folder and open the folder enemy. And in that you'll see a folder called enemy movement. We're going to drag and drop that onto Zombunny in the hierarchy. And then once you've assigned it, either double click enemy movements icon or go to the cog icon and go to edit script. But basically we're opening that for editing. And when you open it for editing, it should look like this. So what you'll notice here is that we have a script that's been ready written for you. Some of the functionality has been disabled. You'll notice the double / symbols at the start of some of these lines. That's commenting. So you can write comments in the script, i.e. just notes to yourself or to co-workers, whatever. But you can also use that to turn functional lines of code into deactivated lines of code. So that's what we've done here. And we're going to come back to this script at some point and enable some of that functionality. But for now, we're just going to explain how this script functions.
This is our enemy movement script, and at the very beginning we have this transform player, and the transform player is going to be what the enemy is going to move towards. You will notice the transform player is not public. With the camera, we had that public transform target, right? So we could click and drag in the editor and the camera knows what it's following. However, our enemies are not going to be in the game when the game starts, right? Our enemies are actually going to be what's called instantiated or spawned later, so whole hordes of them can appear. As such, we can't just click and drag the player onto them. So what's going to happen is they're going to have to find the player on their own. So for now, that's just transform player, no public. We also have a reference to a nav mesh agent, which is the component we put on the Zombunny previously. This is just our reference to it, which we've called nav. Now down in the awake method here, we are, first off, we are finding the player. Okay, so we have player, which is that transform before, player equals game object dot find game object with tag. So if you remember previously when we were setting up the player, we gave the player the tag player. So now that we've set the player with the tag player, we can find that player using this function. So basically what it's going to do is it's going to go through all of the game objects in our scene. It's going to say, hey, do you have that tag? Do you have that tag? You know, so on and so forth. So it finds the one and it gives it back. And then what we're going to do is we're going to say dot transform, which is going to give us a reference to the transform of the player. So basically where the player is. So we're storing that in our variable name player. Next, we have a variable named nav, and we're just setting that equal to get component nav mesh agent, which is basically going to pull a reference to the component we have in the editor. All right, so at this point, we're just setting up. Then down in our update function, you'll notice we're using update, not fixed update. As this is a nav mesh agent, it's not keeping in time with physics, so we're just going to use the regular update. And inside there, we are going to say nav.setDestination player.position, and that's it. So nav being the nav mesh agent, we're saying, hey, that's where I want to go. Where do you want to go? I want to go towards the player. And that's it. The nav mesh agent goes, cool, I'm going to head towards the player. And the nice thing about doing it this way is that the enemies aren't going to bump into each other, right? They're not going to crop in and out of each other. They're going to move around all the creepy baby arms and Legos and weirdness that we have in the scene there. And they're going to viciously and unerringly attack you with extreme prejudice and violence. The nav mesh agent makes it very easy to do these things.
Yep.
And that's the whole script. We'll revisit this script later when we want to uncomment and re-add in that functionality that you see is currently grayed out.
So we can switch back to the Unity editor right now. We don't need to save anything because we haven't actually edited it. But I do want you to make sure that you have applied it to the player. So the Zombunny in the hierarchy should have the enemy movement script attached to it. I'm going to save my scene, and I'm going to press play to test my game. When you press play, it now follows the player. We don't have any coding for attacking yet, or anything like that. So it's not going to do any harm to you. You can just kind of walk around and kind of push them around. That is the end of phase 4.
I forgot to actually move the character back. Let's go ahead and move that guy back to the origin. There we go. Okay, so now if I hit play, Interesting. So that's an interesting little aspect there. If you can notice, I'm like within the area of the clock there, and it's still not chasing me. So I've gotten to a point where um, I can kind of avoid them a little bit. A little bit. Interesting. Okay, so I haven't really caused it to stop that much. Excuse me, folks. The lack of sleep is definitely catching up to me. Okay, so yeah, once again, I'm in an area that they can't reach. So I don't know if that's going to be, you know, uh, um, I don't know how breaking of the game that would be. Okay, uh, is the collision area of the bunny more than where I'm currently at right at the moment? I don't think so. So technically, if it's just going to be the zombie bunnies, then you could pretty much put yourself right here underneath the dresser, and the zombie bunnies will not even be able to touch you. At least that's what I'm seeing right here. So something is going on. Something might need to change. Not 100% sure. We've they've pretty much did everything to include the um, adding a single enemy in there, and just by doing a regular test, I'm afraid that I'm in a position that they can't get to right at this moment in time, which means that uh, you can basically play the game without any kind of um, possibility of losing your life, for example. So mm, I don't know. I don't know what's kind of going on, whether or not there's any kind of something that pushes the player out from those locations, or if the enemies have some kind of shot mechanism. But even if they were to shoot, I'm putting myself here, and they're not even moving. So what's excuse me. Um, have I basically found a spot that is breaking the game in a sense? Is this a bug that um, if you're designing a game, the tester would find and go, oh, hey, guys, the zombie bunnies can't get to the player here, so I can pretty much play forever if I wanted to. I don't know. Sorry, I thought I saw something outside. But for now, um, that's that's for a problem for another time. So
The next thing we're going to jump into is the new UI system. And the first thing that we're going to do is to click the 2D mode. So in Unity 4.3 we introduced some 2D features, and they're also useful for the GUI. So in the scene view there is a little box here called 2D. So if you enable that, you'll see that the scene view switches to a completely flat representation, and that the gizmo in the upper right disappears. Looks like this. What we're going to do is to create a canvas. So the way that the new UI system works is that everything is based off of a canvas. So if you go to Game Object, you can go to UI and create a canvas. Game Object, UI, Canvas from the top menu. And we will rename this object from Canvas to HUD, HUD, capitalized, Canvas, HUD Canvas. Just to give you a little bit of background information, the UI system is based around the concept of a rect transform. So rect, short for rectangle, has a number of ways of displaying a rectangle on the screen, and every child object, every UI element is based off of the parent object's rect transform. So in the case of a canvas, you will see that in a particular mode, such as screen space overlay, the rect transform's values are being driven by the game view. So the first thing I'm going to do is to select my HUD canvas in the hierarchy, and I'm going to frame selected. So if you hover over the scene view and press F, you will see an outline of this canvas. So that's driven by the game view. You can see if I drag the game view, the actual shape of that is changing. So that HUD canvas is going to have all of our child elements attached to it, and it's going to stay to the scale of the screen. So if you're working for different resolutions, it's going to still stay full screen. So it's driven by this canvas component. Canvas has 3 modes: screen space overlay, which is just filling the entire screen; screen space camera, which can have UI perspective; and world space, which is for things that are intrinsically within the 3D scene. So for example, you might have a speech bubble popping up from a 3D character. We're going to stick with screen space overlay, so we don't need to worry about that. Pixel perfect can be used to make sure that all of your graphic elements are pixel perfect, but we don't need it for what we're doing here. And graphic raycaster, we don't need to concern ourselves with at all. What we do want to do is to add a component before we do anything else, which is a canvas group. So what a canvas group does is allows UI elements to have an alpha, and it allows you to toggle whether they're interactable. So for our entire UI, we don't actually want interaction. So we don't want to put in buttons or anything like that. We're going to be putting in elements that would be interactable, but we can cancel them out by, on the canvas group, removing that. Also, because we use a raycast from screen space to the quad in order to control the character, we don't want this canvas, which is going to be effectively rendered in front of everything, to block that raycast. So on your canvas group, interactable and block raycast should be unchecked.
Real quick too is, obviously the canvas is very big, and just want to clarify real quick, it's so big because it maps 1 pixel per unit, world unit, so that we get the highest level of fidelity in our graphics. So if you have a graphic that is 512 pixels by 512 pixels, it's going to be drawn 512 units by 512 units. And if you recall, the capsule collider on our character is like 0.6 units wide, so 512 units is very, very big.
So that's why you're seeing the canvas display huge in here, and then the level looking tiny down in the corner. There's nothing to worry about whatsoever. One trick that I don't want you guys to do right now, because it can lead to confusion, is that you can use layers to disable this. So all new UI elements are automatically put on the UI layer, and what you can do is just choose nothing and then UI to only show the UI. But we don't want to do that. We're just going to work with it out as it is like that. Okay, so the first thing we want to do is actually get a HUD element into this. So we're going to create an empty child. There's another way of doing this. So I want to basically give you an example of each way of doing certain things. We can select HUD canvas, and from the top we can go game object and add things. We can go to the create menu here, which now has create empty and empty child as of 4.6. But we can also right click on a game object we want to create an empty child for. So I'm going to right click and go to create empty child. And I'm going to rename this game object Health UI, capital H, capital UI. Now, the advantage of adding a child directly to this rather than making it separately and adding it is that because we selected that HUD canvas first, Unity knows that we're trying to add another UI element. So instead of the standard transform component that it adds to any new game object, it's adding a rect transform. And you can see that you have a slightly different looking component than you're used to. Just to draw your attention to something else to do with UI. So this is our new empty game object, this square in the middle. We also have up at the top a brand new tool, the fifth one there, which is our rect tool. And you can use that to scale things, you can use it to rotate. And you'll also notice that when you drag these things around, we have snapping, and we have these mysterious looking triangles in the center. Those are our anchor points, and they're a very powerful way to position your different UI elements, and we're going to show off how you use some of those throughout the day. The first thing we want to do is to set up our Health UI in the lower left of the screen. There's a button which may not immediately appear to be a button on the rect transform. It's called the Anchor Presets button, and what it does is give you all of these different presets and a couple of different modes using Alt and Shift in order to be able to lay things out. So the rect transform's position is based off a number of different factors, and when you're in different modes and have your position in different places, the actual properties that you're getting, the position, X, Y, Z, the width and height, will be different depending on how things are anchored, i.e. where those particular anchors are positioned. So when they're all positioned together, so for example if I just move this and move my anchor to the top right, then my position is relative to where those anchors are. So as I drag my canvas in, you can see that that stays with the right-hand edge. So
Interesting.
it's all,
Okay.
all based around this thing, but we're going to use some of the presets for this to make it a little simpler. So what I want you to do is to, with the rect transform button open, hopefully you can see this menu, we're going to, first off we're going to hold Alt, because Alt is also going to set the position whilst moving the anchors for us, and we're also going to hold Shift. And then we're going to click on the lower left preset. So you can see they've got titles here. We've got bottom and left. We're going to click there with Alt and Shift. So you see if I hold Alt, it moves the box. If I hold Shift, it highlights a blue circle, which is our pivot. And we click there.
If you have trouble remembering that, it also says it right at the top.
Yeah, we've got also
Shift
set pivot.
sets the pivot, Alt sets the position.
Then what you should see
Okay.
is that in your scene view, that you have something in the lower left. It looks like this. Then I'm going to go ahead and set the width to 75, and I'm going to set the height to 60. So the next thing I'm going to do is to add those child elements, this heart icon and the slider. So I'm going to again want to add something directly as a child. So I'm going to right click Health UI this time, go to UI and choose Image. So UI image is exactly what it sounds like. It's any way to get a texture or sprite, as we call it in imported form, into your UI layout. So once we've added this, rename it from image to heart. Then in the rect transform, we are going to set the X and Y positions, if they're not already, to 0. And I'm going to set my width and height to 30. So what you should see is a white square in the lower left of your screen. So you should have your Health UI parent object, and you should have your heart, which is a white square right now. So when you add an image in the new system, until you give it a source image, it has a white background. So it falls back to using its color property. So that's just a really handy way to see where the outline of the thing's going to be. And if you didn't want to see it at all, you could always turn down the alpha value, the opacity of the image. But we do have an image for it. So we're going to, on the image component, use the circle select to look into our assets and choose heart. So click the circle select to the right of source image and choose heart from the assets.
I'm
And
sure
when
you've all all are noticing that the heart and the white box and everything are actually appearing in the lower left-hand corner in your game view. So it's very easy to set things up because you'll see what it will actually look like in the final project.
The next thing we're going to do is to add in a slider for our UI. So we have the heart, and next to it we want to have the amount of health displayed to the user. So I'm going to reselect my health UI because I want to create a child of that. So I'm going to right click, do the same again, UI, and this time we're going to choose slider. And we're going to rename this first of all to health slider. So F2 on PC, return on Mac, health slider, capital H and S. Then I'm going to set the X position in the rect transform to 95, ensuring that Y and Z are 0. So what this is effectively is a slider. So you can use this for a number of different things. If you have settings in a game, you might want people to drag a slider and set something. We're using it slightly differently. We're using it in a non-interactable manner. And basically, we don't need to worry about the handle. So what I want you guys to do is to open up Health Slider to see the child objects that are standard within a slider. You'll see that we have fill area and handle slide area. So the fill area is in charge of the background and the fill itself. So the main space that you've got to fill and what's going to be behind it. We don't want the handle slide area at all, so we're going to remove that from the hierarchy. So leaving the fill area, select handle slide area, and to delete something, if you're on a PC, delete key. On Mac, command backspace will remove it from the hierarchy. And you should then lose the handle in the game view and scene view, just be left with the actual slider's space itself. So we want to set up what this actually does. The first thing we're going to do is look at our slider component. So the slider component is basically all of the different rules about what it's going to do. It has an interactable checkbox. We know that we don't want to actually have any interaction here, but because we place this under the canvas, which itself isn't interactable, we don't need to worry about the sub-assets having interactable checkboxes. So we don't need to go through and uncheck all of those. The canvas, being the parent, is handling all of that for us. Because it is something that you can interact with as standard, we have a transition. So we don't want any of that either. So we're going to select transition, none. Then we want the max value of this to be equal to the starting health effectively. So I'm going to set the max value to 100. Then I'm going to change the value also to 100. So if you look at the game view, when I adjust this slider, you can see that that is the value that we're getting. So when I set that to 100, I know that I can write some scripting that addresses this slider and decreases that each time we get hurt by an enemy.
Okay. Okay. So the max value is the amount for the maximum that you can have for it, and then you have the value that of the stunning bar that basically kind of mimics if the player gets hit, their health continues to go on down, but it will never go above the max value.
Then what we're going to do is to have some kind of visual feedback when you do actually get hurt. Because that slider in the lower left is kind of small, we want to have the screen kind of flash like it would in a real game every time you get hurt. So we can do that using a UI image as well. So what we're going to do is to go back to our health UI. So reselect health UI, right click. This time we're going to add another UI image. We're going to rename this damage image. And because it's a brand new image that's just kind of sat in the lower left right now, we want this to be over the entire screen. So the entire screen kind of flash red each time you get hurt. So there's a very quick way with the anchor presets yet again to stretch this over the entire screen. So here's what I want you guys to do, is to select damage image, drag it up and drop it onto HUD canvas which will make it a child of HUD Canvas instead. Then we can collapse Health UI. So once you have made it a child of HUD Canvas, you can then go ahead, select, and then Alt-click on the lower right anchor preset, as I'm showing you right now. Alt-click there, and you should have then white covering your entire canvas.
Okay.
And then the final thing we need to do is set the alpha to 0 for this. So we're going to worry about the color in our scripting later, so don't worry about that now. But to set the alpha to 0, we just click the color block and then drag the A for alpha down to 0. Obviously, if you have done that, please do save your scene. Very important.
Okay. So far, I have not encountered any kind of problems. Gone through 2 tutorials right at this moment in time. I mean, there was obviously differences between what's currently available for the IDE and what was available 5 years ago, but they're still showing enough that I can interpret what is necessary on that. So, I still kind of wonder why they have the complete game in there, and there was I was fiddling with it last time around. Hmm. I was kind of I forget exactly what it was kind of referencing. I had and last time around I had like that little pop-up that it was showing complete game under the scripts. I forget exactly where that was, and I'm like, why is complete game being shown in the in that listing of different scripts? Why is it even needed? I just can't remember where it was exactly. I'll have to look at it a little bit later. So, okay. Oh, boy. Sorry, folks. I'm trying to stay awake on this. If you probably noticed, I was kind of dozing off a little bit there. Network error, please try again. Oh, come on. Damn it, don't do this to me. I'm hoping that my stream's still going. I mean, based off of what I'm seeing here, it's still going, so my phone just decided that it doesn't want to continue on, I guess. Okay. There we go. Weird. Okay. Well, Okay. Boy. What's going on here? Yes, yes. Well, probably what happened was the stream probably gave out, and now it's trying to record again. If you look on my Twitch channel, you'll see like videos where it's like separated out into like 10, 20 minutes kind of thing. So there's some amount of glitches from time to time that just throws out the consistency, the complete uh, run through of the stream. It's one of the reasons why I'm recording the stream at the same time, and I upload all my streams. You know, uh, no cuts, no editing, no nothing. Straight onto my YouTube channel, so that anyone can kind of see what I go through. So, okay. But with that being said, we are moving on to the next one here. Player health.
The next thing we're going to do is look into player health. So obviously we just created a slider to represent the health. We now want to actually implement that.
So we have this health UI, and so the next component to this game that we want to have is we want to have the player have health that is able to be taken away and is able to also interact with our UI that we just created. We also want to have the enemy have the ability to attack the player and thus take that health away. And then from there, we're going to reverse the roles. We're going to give the enemy some health and then give the player the ability to take that health away. So what we're going to do to start is we are going to go to the scripts folder, and we are going to locate the player folder, and we should find a script called player health. So we're going to take that, and we are going to click and drag that onto the player game object in our hierarchy. So we'll drop it there, and if we click on the player, we scroll down, we should see player health script as a component. Also, we are currently still in this view where we're really zoomed out and we're focused on the canvas and all that stuff. So why don't we take a second, we'll come out of 2D view here by just, again, clicking on the 2D button right there, bringing us out of that 2D mode. And then if we want to get to the player quickly, we can just double click on the player's name in the hierarchy. We'll zoom us right in there. Just sort of brings us back to where we were previously. We now have the player health script on the player. So we're going to open it up and take a look at it. Before we do, be sure to save your seat. And let's go ahead and pop this open. All right, player health. So we start off with our player health with a whole bunch of variables. And so let's just step through and see what each of these are. So the first variable here is our starting health, which is a public integer, which dictates how much health the player.
Okay, so we, instead of allowing the individuals working through this tutorial to kind of copy all of this information, they pretty much gave it to us automatically. I kind of liked their previous coding aspects in the sense that every time they include the type and the name and so on and so forth, they actually kind of described, what it was kind of meant for. Now, for someone that has played games before, then a lot of this stuff is pretty much standard, kind of aspect. So, I mean, you can see here, public integer, starting health, current health slider, damage image, death clip, flash speed, so on and so forth. A lot of this stuff is, what you might consider like, just standard gameplay values kind of thing. So, so on one hand, I can understand them not even allowing us to put in those like default values per se. But at the same time, um, it it doesn't like reinforce the whole process of the health being discussed per se. So I don't know. Uh, I've I was at a college at one point in time where their motto was "learn by doing." So this isn't doing. This is giving. So I don't know.
Player has when the level first starts. Next, we have an integer for current health, which is how much health the player will have after they've been damaged or just at any given point in the game. We have this health slider, which is a slider game object, which is the reference to that slider UI element we created earlier. Now, a good note right here, we're accessing slider, right, which is part of the new UI. In order to access this, we need to include using unityengine.ui.
Okay, here's what I'm kind of confused about here. Um, sorry, I'm kind of wondering about here. Um, so I'm gonna highlight that, and I'm only seeing it being referenced once here, which is starting health. Okay, so upon awake, they're setting the current health equals to the starting health, right? So, hey, starting health, the current health is now equal to the starting health. No problem. It's quite understandable. They have kind of a constructor that is, taking a default value, which technically should be static because you're not changing it. Um, and you're throwing it into the current health. Nowhere in here do you actually change the starting health at all. So, um, that's the reason why I'm like, why isn't this static? Why isn't this like a constant value kind of aspect? So, um, but they're not doing that. Second point that I'm kind of confused on. They do this value of starting health is equal to 100, but yet over here on the um, uh, so the hearts health slider. Oh, I forget exactly. Or was it in a player? There was one that actually had the max value. Sorry, I'm trying to remember where exactly it was. Um, there it is. Under the health slider. Max value is 100. Why aren't they referencing that? Why are, you know, one of the common mistakes that a lot of programmers make, believe me, I'm one of them, so, I've made that mistake before, is uh, what what they what I've heard sometimes called as magic numbers. Okay, um, numbers that you put in under the integer value, and it's like, well, here's the problem with this. If you change this to say 500, for example, um, how is it, you know, how does the health slider here handle that? If you put 500 here, you're always going to be at 100 until, the enemy knocks you down to below that, you know. or or the system might look at the 500 and go, wait, hold on, doesn't match up with the max value of the slider. I have a problem. There's an incompatibility here. What's going on? Um, so uh, if I was kind of going about doing this, again, uh, I'm not 100% sure here, because I'm following what they're doing here. If I was to do something along these lines, I would get rid of the addition, or the assignment of the value to starting health, and then I would do something like um, starting health is equal to health slider dot uh, max value, or something like that, or something. I don't know. I don't know the system right at this moment in time, but I mean, my point is that you have a max value here at 100. Okay, you don't need to arbitrarily add equals 100 there when you have it already, when you have the value already kind of set as well. So, um, if I was to do the awake kind of aspect, I would try to get this particular value here, so that I can assign it directly into starting health. That way there will never be any kind of confusion. I will always set, the value here, like 500, and it will always set the starting health to that value. So, not exactly great design here right at this moment in time, but I mean, it's a tutorial, so I mean, I gotta follow what they have right at the moment. But um, they're adding in a lot of different what they, what I've heard is magic numbers, um, uh, values that um, don't really have any kind of uh, what's the word I'm looking for? Um, Numbers that can mean anything, really. Okay. Um, I could put 100 and think, and say that, oh, this is a percentage. Not actual hit points, but a percentage kind of aspect, and that could be uh, a that could be a percentage of 500, for example. I could have 100% right here, but I actually have 500 hit points. You see what I'm saying? It's one of those aspects where it's like you really want to limit yourself as to, you know, uh, the 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 numerics there. You always want to try to, um, if you have constant values, set those constant values at a particular location and use a reference to that location. That's it. You know, you do it once, and You, that's all you need to worry about. You know, you don't. Um, you know, doing doing something like this has the potential of causing errors later on, because someone could look at that and go, "I have no idea what they're trying to reference here." So, um, as a programmer, you have to kind of look at it and go, "Hey, no, wait, we're going to have to change this into something better change it into something that I know what exactly it's referencing all the time. Okay, so that's why I'm like looking at this. I'm like, oh, where's the static? Where's the constant aspect of this? Because I mean, starting health, you know, based off of their health slider here is always going to be 100. So slight design flaw in my opinion. But again, like I said, this is a tutorial, so
If you don't have that line of code at the top using UnityEngine.ui, you're not going to be able to use text, images, sliders, any of the new UI components. So just keep in mind you have to have that. After the slider, we then have a public image damage image, which is, again, a reference to that damage image item we created. We have an audio, which is our death clip. So unlike our hurt clip, the death clip is going to be what's called a one-shot audio, where we basically are saying, we're not going to play the hurt sound anymore. This is the sound the player makes when the player loses the game. We have a public float flash speed, which is how quickly the damaged image flashes up on the screen. And then we have flash color, which we have set to 100.1, which means completely red and a tenth of the way completely opaque. So it's mostly transparent and red. Next, we have some private variables. The first is animator anim, which again is a reference to our animator components. We have a reference to our audio source, which is we call player audio. We have a reference to the player movement script. So this is the first time we've seen this.
okay. I want to pause real quick there because he just made a mention about how because there is no public in front of these, that these are automatically set to private. Um, Again, I don't know C sharp, so I don't know what their modifiers are. Their um, access modifiers are. So, um, I know Java's access modifiers, public, protected, private, and the non-assigned. Um, so I'm looking at this, I see public, and I see non-assigned. Non-assigned in Java is not the same as private in Java. So that's why I'm looking at this. I'm like going, well, how much of a difference is C sharp and Java? I'm gonna assume, and obviously there's multiple differences because C sharp I'm gonna assume is based off of C and therefore has some similarities to that, but not actually stating something as private doesn't necessarily mean that it is indeed private, at least based off of what I know of as in um, C and Java. So I don't know. So it's one of those aspects where it's like I'm getting a little hurt. I'm at a slight disadvantage here that I don't know C sharp. So he could be completely correct. It could be that there's only two particular access modifiers, the public and private, and that's it. So not actually um, declaring a variable and a function as private, uh, or not declaring them as public automatically sets them to private. I don't really know. That might be the thing in C sharp. So uh, so that's something that I'll probably need to be kind of looking at a little bit more in my off time, I guess. So we'll see.
We've created a reference to another script that we've already written. You all remember writing player movement earlier today, so
Okay.
now we're actually getting a reference to that script that is on the player so that we can prevent the player from running around once the player's dead. We have to have a reference to it to do that. So we're going to be seeing some script interactivity there. We have two Boolean values. One is dead, which will determine whether or not the player is dead, and the other is damaged, which will allow us to know whether or not the player has taken damage. The awake function here is going to be fairly similar to what we've seen before. We're starting by getting a reference component to our animator. We're then getting a reference to our audio source. Player audio equals get component audio source. This is slightly new, so here we're doing player movement equals get component player movement. And you'll see to get the component of the script we've created, we just use the name of that script. The script is called player movement. I want a reference to it, so I get component player movement.
Which
Again, we
makes
have
sense.
some commented out code. We'll revisit this script and re-enable that later. And then we're going to say our current health is equal to our starting health. You'll recall awake gets called right at the beginning when the game first starts up, so we're just going to set our current health to its max value right there. Update method. And our update method is really simple. Update is simply concerning itself with whether or not we are flashing that red damaged image, right? And so basically what this function is saying is, hey, if we are damaged, if damage has been taken, what we're going to do is we are going to set this image to our flash color, which you'll recall is red with a 10% opacity. So that's going to happen immediately. It's going to flash this red. Otherwise, if we're not damaged, okay, what we're concerned with is fading the damaged image away. So it flashes red, and then we're going to fade it back to transparent. And we do that, again, using lerp. Before we use vector3.lerp with like the player's movement. So now what we're doing is we're doing a color.lerp, which is the exact same concept. We're moving from one to another, right? But instead of vector threes, we're doing color. So we're doing color.lerp, and we're passing in the current color of our damage image, and then we're passing in the color that we would like, which is completely clear, completely invisible, and then we have our flash speed times time.delta time. Very much like the smoothing that we had on the camera, right, as it would follow the player around. Here we're just smoothing or transitioning from the color that it is all the way to transparent. And then finally, at the end of every update cycle, we're setting damage equal to false. What that basically means is the moment we take damage, we're then going to set damage back to false after showing that damage image. In the next bit here, what we have is a function called takeDamage. Now this function is also unique because it is a public function. As such, what this means is other scripts and other components can call this function. TakeDamage is a special function in the script in that it's not called in this script. Other stuff calls this function, right? So when the enemies attack the player, they call the takeDamage function. And so again, that script interactivity is important. It has to be public or else this isn't going to work. The one parameter or argument for this function is int_amount, which is how much damage the player has taken. Next, what we're going to do is we want to ensure that the player has, the player flashes.
Okay, I'm gonna stop here real quick. In my previous stream, I believe last stream, I was talking about how, the access modifiers allows for whether or not a method or whatnot in Java can be accessed by the package, the world, and so on and so forth. Doing public here means that anything can use to take damage. So I can make something that's completely outside of the scope of the code call this particular function and potentially, do more damage to the player, kind of a thing. So, this is one of the problems with, the fact that, I don't know the access modifiers of C#. It sounds to me like you'd want to have something along the lines of unassigned or protected, so that other objects within the full scope of the application can access that, or some portions of the script can access this particular um, function to damage the player, but because it's public, that leaves anything to call that and damage. So um, uh, it's one of the shortcomings of um, knowing one particular language over another kind of thing. You're not excuse, excuse me. Sorry about that. Didn't mean to cough in your ear there. Um, the it's it's one of those aspects where it's like, okay, with making it public, you're allowing for other things to have access to it. That's true, but at the same time, it has that potential of allowing for anything to call that particular function. So um, you have to be like really careful when you're trying to use public. So um, I don't know. It's one of the downsides of getting to know one particular language over another. You don't know. Um, you don't know whether or not how your knowledge of one particular language, such as Java, can translate very well with C sharp, which are eh, supposed to be equivalent. So um, the when it comes to C, though, it's like you have to be really careful when you're using public. So you want to have that. Um, you want to be able to for C, it's better to have like that. I guess you might say, it's not actually an object in C, but still, um, you want to have that, get and set method kind of aspect, so you don't actually, um, you're not actually, calling the function without actually, having that object kind of. You understand what I'm saying? Um, so again, I don't know how C sharp handles that, so um, I would imagine that you'd want quite a bit of stuff to be private at the very least. Um, and then you have the object, calling that particular function with a passed-in parameter to handle that. But I don't know. Again, not sure. So we'll see what happens. Um, moving on.
Is that red image. So we do that by saying damaged equals true. We detract the amount of damage from our current health. We do that using a little shorthand here by saying current health minus equals amount. What that little shorthand means is we're going to say take the current health, remove the amount of damage, and then put that back into current health. So it just basically reduces by that amount. We are then going to take our current health and pass it into the value of our slider. And so we see the slider slowly shrink as the player takes more damage. Next, we're going to play our audio, and if we recall, we set up an audio source on the player in Unity, and we gave it that player hurt audio. So basically, every time the player takes damage, they're going to play that hurt audio. All right, and then finally, we're going to say, hey, by the way, so the player's hurt and all that stuff, is the player dead, right? And so what we're going to do is we're going to say, hey, if their current health is now below or equal to 0, and they're not already dead, that's what that and not is dead, make them dead. Right? Because there's no sense in making them dead if they're already dead. And if that happens, we're going to call a new function called death. Death is a function that is in this script. It's not like built into Unity or anything like that. It's actually the very next function we're going to look at. So basically, if the health drops below 0, we're going to call this death function. And here's what the death function does. So the first thing the death function does is sets is dead equal to true, saying, yeah, okay, player is dead. Next, we've got some disabled code. We'll come back to that. Next, we say anim.setTriggerDie. Remember when we did the animator controller, right, in the animator window, and we had that second parameter, which was die, which was a trigger? This is where we play that animation. So we say setTriggerDie, and the character plays their death animation. We then set the audio clip of the audio source to this death clip, right? And then we play that sound, the sound the player makes when they lose the game. And then finally, here's where we access that script, the player movement script that we added as a component. We say player movement.enabled equals false, which basically means no more movement. That script component on the object gets disabled, stops reading our inputs, player stops moving. And so this is that script in its entirety. So let's go ahead, we'll close this down here, and now we're going to return to the Unity editor.
Okay, okay, maybe they haven't addressed it just yet, but death clip hasn't been set. Unless I'm missing something. I mean, you're creating a value, an object called death clip. But it's not being set anywhere. You're using it, but there's no value in it. So how does the audio clip know what death clip is all about? That doesn't really make any sense. You know, once you create an object like that, it's filled with nothing. It's allocating space for that particular object or value or something like that. It's creating that memory space for it. But it has nothing in it. It has garbage in it, or what we call as garbage. It's because we haven't actually set anything inside of it yet. All it has is just random data in it. Okay, it's like this container right at the moment. Okay, I want to basically fill this up with all reds or something like that, right? You guys can kind of see it, right? Yeah. Okay. But right now it's all different colors. So in order for me to, I have to, create the object, and then I later say, I want this entire thing to be red. Okay, it's just like that this public color flash color is equal to new color. Okay, I'm assigning that new color and all the values into flash color. So, I mean, you can see death image here. It's taking in the color for flash color into it. Okay, it's assigning the into flash color into the color field for the damage image kind of aspect. So let's see, health slider, the value of it is getting, it has the current health added into it kind of aspect. So the only thing that we're seeing here that hasn't been Um, well, actually, there's a couple problems here. Let's see. Um, okay. Now, when you set some values there, okay. Um, like I said before, okay, you're finding a memory location and you're um, that particular memory location could have whatever it's contained in there. Okay, in the case of a boolean, it could be just ones or zeros kind of aspect. The whole flag is true or false. Okay, um, these aren't set. Same as death clip. Okay, these are values that are not set prior to usage. Like for example, damaged is not set prior to this update. Okay, it is not set in awake. Okay, so how do you absolutely certain that it's set to false every single time? You don't. You're not sure. Okay. Same thing with death clip. There's no instance of there's no reference to it or what's inside of it. So how's this working? Um, you know, so if again, I'm gonna continue moving forward in this tutorial, but if I was working on this, okay, I'd first be doing something like this, something like this. Nice accent there, Jim. You know, so I can guarantee upon creation that they're automatically set to false. Okay, you don't want to make assumptions that it will always be made false. You want to make sure that they're always set to false, no matter what. Um, and then, I don't know what this is supposed to reference, but I mean, it should reference something, like the audio clip dot, um, um, I don't know, instantiate or something like that. I'm not sure. It's like, the death clip has nothing inside of it to my knowledge here. This is just creating the object, and that's it. There's nothing inside of it. Why? Mm, and the audio, player audio dot clip is referencing this object, but there's nothing inside of it. So how's it supposed to play something that doesn't have anything in it? Unless that clip is going to be referenced later on in the program that I'm not sure about, which could be a thing. I don't know. Um, maybe audio clip um, has a value called death clip automatically inside of it. I don't know. Like I said, I'm not sure why they don't fill it with data. I don't know. Well, I'm gonna leave it the way it is right there because not having them set is kind of poor design. I mean, I guess you could probably put these up there, um, but you always want to try to do it like um, every single time uh, you start the game. So you always want to kind of reset those values. Um, so seeing that these are data values within player health, whenever there's an object of player health inside the game already created, then um, then uh, these will never kind of um, be reset per se. So I don't know how often Awake uh, is done. They said at the very beginning. So um, but yeah, okay. Uh, so uh, that one, no idea, no idea. And they didn't even cover restart level, did they? I didn't see them cover that.
Disabled equals false, which basically means no more movement. That script component on the object gets disabled, stops reading our inputs, player stops moving. And so this is that script in its entirety. So let's go ahead,
I state that they didn't go for it because it's not there. They didn't actually, they didn't address it because uh, they, the script here is either a most recent version and therefore they don't cover it here at all, or maybe this is a portion of the tutorial that you cover later on. I don't really know. So I'm going to assume that it's a portion that it will be covered later on in the tutorial, like part 9 or 10. We'll find out. Yeah. Moving on.
close this down here, and now we're going to return to the Unity editor. And again, I reiterate, make sure that if you click on the player in the hierarchy that you see the player health component at the very bottom, which will let you know that you put that script onto the right game object. So now that we are, we're back here and we have this player health script component on the player game object, what we're going to do is we are going to start filling in some of these values. So we can see his starting health is 100. That's fine. That's what we want. Current health is 0. That, again, doesn't matter. That's going to be set in the awake function. But here we have this health slider property, right? And it's currently empty. And this is where we establish that link between the UI that we created and the script that we've just added. So if we look in the hierarchy, we see the HUD canvas, which we expand, and then the health UI, which we expand. And right here, we have our health slider. So if we were to take this health slider and just click and drag and drop it into the health slider property, that will link the health slider UI component with this player health script. So now we can update the health via the slider. Next, we have this damage image. So again, I'm going to come up and I'm going to grab my damage image from the HUD, and I'm going to click and drag down into the damage image property in the script. And then finally, I have this death clip, which currently says none. I'm going to click the circle select here, and I'm going to look for player death. And I'm just going to double click, and we'll see that that gets added there. So the next thing I want to do now, so the player has health. The health is interfaced with our UI system. So as the player loses health, the UI system reacts, and all that's done. Now what we want to do is we want to give the enemies the ability to actually attack the player, and thus we can see that this all works and see the interactivity of our game objects. So what we want to do is we want to look in the scripts folder, and we want to locate the enemy scripts folder, and we're going to locate the enemy attack script. And what we want to do is we want to click and drag that onto the Zom bunny. Again, when we select the Zombie afterwards, we should see enemy attack at the bottom there. Let's go ahead and open up enemy attack. So enemy attack. So a lot of this stuff is going to be very familiar to you by now. But again, we're going to start with a few public variables. The first public variable we're interested in is a public float time between attacks, which is 0.5. It basically is the amount of time between each of the attacks. And then we also have a public integer, which is the attack damage. So how much damage does each of these attacks do to the player? Then we have our private variables. And again, these are very similar. We have an animator.
Again, I have to question as to why these aren't constants, but whatever. We're moving on.
Variable named anim, which is going to store a reference to our animator component. We have a game object parameter, which is going to be the player. So again, the enemy will be able to attack the player, so it needs to have some reference to that player. We have a reference to the player health script. So now this is kind of new. We have the enemy referencing a script that we have created that is on a different game object. So the player has a player health script, and the enemy has a reference to it so that the enemy can then damage the player. We have a bit of code that's commented out. And then we have a Boolean value, player in range. This will be set to true whenever the player gets close enough for the enemy to attack. It'll be set back to false when the player gets too far away. And then finally we have float timer. And timer is a variable that we're going to use to keep everything in sync, to make sure that the enemy's not attacking too fast, not too slow. In our awake function.
Okay, I'm stopping it here because I'm now kind of wondering why did they even make this public? I mean, if they're referencing the object of player health, why have it public? They can keep it private and they can still reference the function. Can they not? I mean, all they have to do is just, let's see. I mean, this right here, is that not possible with the fact that you're already referencing the object? I mean, the functions, contained within the object should be still, should still be used, unless I'm remembering it incorrectly. Not sure. Maybe I'm just not remembering correctly. But I thought that if you have that object in there, then you should be able to kind of access the functions contained within that Now, well, no, maybe I'm wrong. Maybe you actually do need public. It's much like the get and set kind of aspect. You want those to be, well, in Java, it's better to have it like under protected, so that it's kind of contained within like the full package kind of aspect. I don't think C# has that, so So it might be public. Okay. Yeah. Sorry guys, I'm just trying to make sure that I'm getting this kind of correctly. It's like I said, it's been a while since I've kind of touched upon this, so I'm trying to get myself back into the swing of things. So
Again, we're going to be setting up a lot of our stuff. So we're doing GameObject.find GameObject with tag player, which again is going to locate the player for us and store that reference locally. We do this in the awake method and then we store it so that we don't have to do it every frame or every time we need it. This is a fairly inefficient call, so we really want to limit the number of times we do that. So by doing it once in the awake function and storing it, we're greatly improving the performance of our games and project. Then we use that player object that we just found and we say player.getComponentPlayerHealth, thus pulling the player health script off of that player and again storing a reference to it. Now with that reference, we have the ability to call that public function take damage we saw previously. And then finally, we do get component animator to set up a reference to our animator component. Now, remember how we created the sphere collider on the enemy that was a trigger? And I talked about how triggers are not used for in-scene effects. And Will was talking about how we use these for detecting collisions, stuff like that, kind of behind the scenes. If we have a trigger on an object and another object comes in collision with that, it doesn't react physically because it's a trigger. Instead, it calls a function. And if we have a function in a script, that function runs. The function's called onTriggerEnter, and it gets called whenever anything goes into a trigger. So here we have void onTriggerEnter, and then inside parentheses we have collider other. Other is whatever it is that collided with this collider. If I'm the enemy and something collided with me, chances are other is the player. And so now I know where that is. And so the very next line is me making sure that it's the player, because we don't want to be able to attack a sofa. We want to only attack the player. And as such, we want to ensure what it is we are attacking. So we're going to say if other.gameObject double equals player. And that double equals is an equality operator. This basically says, are these the same thing? So if
okay, I'm pausing it right there because there have been issues, at least through Java, with the double equals. Okay, especially um, when it comes to objects, because it might not always be an exact duplicate, you might say, between the two. So sometimes like in Java, we've had to kind of use um, something else like dot equals, for example, to verify that one does indeed equal the other kind of aspect. Now, I can't remember if that applied to objects or not, but the double equals was not always a tried and true method of verifying whether or not an object equals an object. So I don't know whether or not that's true in C sharp. Um, it might be true. I'm not 100% sure on that though. Um, I've heard that that's dangerous for any kind of uh, for some coding aspects to it. So um, I forget it. It's been a long time, so I forget exactly which um, what is like a guaranteed in Java for verifying that an object is indeed equal to another object. Um, it's been a long time, so I don't really know. I can't really remember. If you're watching this and you know what I'm trying to refer to, then leave a chat message. Let me know, or leave a comment. Either one. Um, But again, I'm comparing different languages here. So what I know of Java, you know, might not always work for C Sharp, obviously. So um, but that's my concern right at this moment in time is the fact that um, the double equals might not always be correct, um, even though it might it probably should be. You know, like this player should be. You know, this object should be the player, but it might not always equal each other. You know. Um, okay. Well. It I guess it depends on the what's the terms I'm looking for. Uh, there's shallow copy and deep copy, I believe the terms are, and the I believe if it's a shallow copy, then that's where the concern is kind of aspect because it doesn't it's not referencing the object completely, or it's not like looking at the memory spaces of the copy completely. So the memory locations could change, the values could change, and therefore your shallow copy does not always equal the actual value. So um, I'm I believe take it with a grain of salt, folks. Um, it's been a long time since I've worked uh, with with objects, so I'm trying to get myself back into the swing of things here. So um, uh, so the double equals, is that more of a shallow comparison or is that a deep comparison? Um, oh, hello, Red Kazan. Uh, Statements, expression, operators set a test for reference equality. Okay, thanks for that. I'll have to look at it a little bit later. I'm assuming that that is indeed a proper way of actually comparing the two. They're red. Um, so um, so yeah, that's why I'm not sure. But thanks for the link there, Red. I'll actually let me try to bring it up. Oh, I don't really have. Do I have the chat message here? No, I do not. Why doesn't it show up there? Oh well, I mean, it is a tutorial for a reason here, right? Actually, let's go ahead and just do a Google search on it. Reference quality identity. Oh, identity C sharp. Okay, let's see what we got here. Custom logic to support reference quality comparisons in your types. Functionality is provided for all types by the static object reference equals method. Following example shows how to determine whether two variables have reference equality, which means that they refer to the same object in memory. Okay. Simple shows why object reference equals always returns false for value types and why you should not use reference equals to determine string equality. Okay. Um, okay, so yeah, this so this right here is actually referencing the fact that what they're doing here with the equals is dangerous. If what I'm reading here is correct, um, they should have been using reference equals, uh, other game object, you know, uh, right here they should be doing something like object reference equals other dot game object and then player. If what if what I'm referencing this is true, okay, because they're not doing that, this is potentially dangerous because it might not always be exactly the same. Um, so um, it's the same thing with Java. You know, you don't want to do equals equals because that's not a true comparison between objects. So um, but at the same time, they mentioned the fact that that doesn't always work for string equality. So at least I believe. Do you concur there, Red? Am I am I stating this correctly? I don't want to like mislead anyone on this. Um, but I believe that's what's going on here. Or let's see. Uh, right. The results might not be what you expect. The same is true for equals equals operators and whatnot. So, right, okay. Sorry, I'm trying to be as quick as I can with this particular tutorials uh, uh, guide, I guess. The going over the tutorials for Unity. Um, so yeah, if I was to update them on this, I'd be doing something like, if object dot let's reference equals other dot game object and then player. And then, there you go. If you had something like that, then uh, then it would be perfectly fine. And of course do that exactly down here on trigger exit. Okay. This right here is the better usage of comparing objects with each other. So that's why it's like this is bad design. So if you're new to programming, don't do this. This doesn't uh, this will lead you into problems. Um, you might not always have the correct comparison with each other, and therefore um, you might have instances where um, the what is it? Um, the Zombunny's, hitting the player, but it might not be the exact player, so therefore, well, um, player's not getting damaged again. Hmm. So let's go. Let's head on back here. So, um, but again, I have to kind of follow along with their tutorial right at this moment in time. So, uh, just bear in mind that bear this in mind, there, folks. What they did there with the equals to equals is dangerous. Okay. So, so if I was making this game, or if I was making any kind of game, if I see that, if I see that one from one of my fellow programmers, I'd be like, no, you, this is bad. Be careful with this. So, okay. Sorry about that. Sorry about the sidetrack there, but
If what we collided with is the player, cool. Okay, we can attack it. If that's true, then we set player in range to true. Now there's an inverse version of that function called onTriggerExit. It tells us that something was in the trigger and it has now gone away. All right, that's just the complete opposite. So again, what we're going to say is, hey, was the thing that left the trigger the player? If it was, the player is no longer in range. So we set that to false. Okay, so we just use this trigger to say, hey, they're close enough. No, they're not close enough anymore. Hey, they're close enough. No, they're not close enough anymore.
okay. Here's the thing. What they could do, okay, before they actually even do this comparison, I'd be doing something like that. So basically, I'm gonna copy this down here as well. Okay. So basically, before it even gets to the comparison, it checks the Boolean. Okay. If the player is already in range, there's no need to. Well, actually, no. That's not actually great, because the object itself might be different than the player. Yeah, never mind. Never mind. I'm making a mistake on that. Because I was thinking, if there's no need to do the comparison if the object is if the player is in range. So, like, for example, like if the Zombunny was like right next to another object, another collision object, and at the same time the player, okay, the player gets damaged, but then the player runs away, the Zombunny is still next to the object, so it's therefore still colliding, but the player is out of range, and therefore the player in range doesn't actually get changed. So, sorry, my mistake on that one. I almost messed up on that. So, yeah.
This isn't actually the attacking part. This is just how we determine whether or not we're close enough. The actual attacking happens in the update. So in the update method, the first thing we do is we determine how much time has occurred. So we start accumulating this time inside the variable timer. So every time update runs, timer gets a little bit bigger and a little bit bigger, and it represents how much time has passed. Then we're going to say, hey, if the timer is greater than the time between attacks, so it's been long enough between attacks, and the player is close enough, we're going to attack the player, right? And you can see that we call the function attack. Then finally, we'll look at attack here in a second. Then finally, we say, if the player's health is less than or equal to 0, that means the player died, right? Our attack killed it and the player died. So we're going to do anim.setTrigger player dead, which, as we recall, will transition us from the moving state to the idle state. Player's dead, so now we all just get to sit around and go, well, that was fun, now what? And so that's how we stop chasing the player around. So if the timer is greater than the time between attacks and the player's in range, we call this attack function, and this is what the attack function looks like. The first thing we do is we reset timer. We're now attacking, so time is set back to 0. And then we are going to say, hey, if the player is alive, player health.current health is greater than 0, let's take some of that away. So we say player health.take damage, and we
Okay, here's the problem with this. They don't need this if statement. They really don't, because this right here is already kind of checking for that. So you know, this if statement right here, okay, initiates the attack on the player, kind of a thing. So therefore their health is reduced, okay, and then they have this if statement checking to see whether or not the current health is equal to or less than 0. So therefore it sets that trigger for player dead, okay. This is a duplicate. This right here is kind of pointless, because based off of this right here, okay, you already know that, you know, if the current health is going to be below 0, they're going to be dead, okay. So you can pretty much, you know, get rid of this and still be fine, okay, because this will attack the player, they reduce down in health, okay, and this checks to see whether or not their health is below 0, and therefore if it's below 0, then it'll do the dead. If it's not below 0, then they still have health left over, okay. The only time you'd actually want this is if for some reason the current health is already at 0. You know, like if their health component is set to 0. That's the only time you'd ever actually want this kind of check on there. This entire script right here kind of needs to be rewritten. So I don't know. But yeah, it's just extra it's extra testing that you don't really need. So
pass in however much damage this enemy does. And so then the player is going to manage the rest of that. And if that happens to kill them, the rest of the update will run and we'll transition into the idle state. And so that is our enemy attack. And so once we've taken a look at that, be sure to save our scene to sort of wrap up what we've just done here. Why not test this? So let's pop back over to Unity. Will, go ahead and get eaten. Oh, and he's taking damage. And we see the health slider being reduced in size. We see the screen flashing slightly. And man, that Zombunny's relentless. I don't think he wants to give you hugs.
The damage image there is quite faint, but we can play around with that with the flash color public variable on player health on the player. So if we wanted to make that more apparent, then we could crank it up a little bit.
Sure.
It would flash a bit more harshly.
Again, he achieved this just now by increasing the alpha of the color on the player health script, right? So obviously, the higher the alpha, the stronger the effect, and so on and so forth.
What? What's going on here? I have my back turned to the Zombunny, and I'm not getting hurt. Oh, there it goes. Okay. interesting. I can just move ever so slightly and it doesn't, the collision doesn't actually happen. There it goes. Oh well. Okay, let's go ahead and stop that. Okay. Thank you for the link there, Red. I appreciate that. So we're moving on to step 7 in this. Oh, why don't you stop that? Okay. Oh, that's a long one.
So we have
Okay. So I don't know if I really want to continue on with this for right now. It, that had quite a bit of discussions and stuff like that. So I apologize for anyone that was, you know, wanting to kind of step through this quickly or whatnot. Um, with I normally end my stream at 8 o'clock. 41 minutes is going to push it over. And even then, I'm probably going to be like trying to figure out exactly what they're going to be doing and how they're coding it. There's going to be some pauses and whatnot, so I think I'm going to go ahead and call it here for the time being. So yeah. Now, I will will give them the benefit of the doubt. I mean, this was done back in 2014 with the whole reference equals aspect, of comparing two objects. They might not have known about it. It happens. Um, uh, they, I doubt it's, you know, uh, that C Sharp didn't really implement it prior to, like just recently, because I mean, I was aware of it when I was going to college um, back in like 2010 or so. So I mean, there's been a couple of years easy, since then. So I mean, or at least in reference to their videos. So it's not like the information wasn't already out there. Now, it could be totally the fact that um maybe these gentlemen just wasn't aware of that kind of distinction. Um, Maybe they've been out into the uh, corporate world, so they weren't actually aware that the double equals wasn't always correct when comparing two different objects. I don't want to make those kind of assumptions. Okay. Um, but just be aware, folks. When you're trying to compare two objects, don't use those double equals. Okay. That's just not the way to go with that. So, um, use the link that Red posted in the chat section. Okay, or do what I did, do the Google search for the reference equals. Okay, because that's the proper way of comparing two different objects in C Sharp. So, now. Like I said, I'm gonna hold off on 7, 8, 9, and 10 for next week. Uh, I'm I'm gonna hold off on uh, testing the problems that I had last week with this latest version until I get done with the survival shooter. So unless one of you guys wants to test out my steps and figure out like if the current version of Unity has a problem with the scripts being loaded into the main camera, like what I was having in the latest versions. If you want to do that, leave a comment, leave a chat message, what have you. And um, this will be going up on my YouTube channel, so feel free to stop on by there, um, see the past videos that I've done, and um, test it yourself if you want to. Leave a comment on that video and let me know, which version you tested out and see if there is an actual issue with Unity, and I'll send it on to the folks over there if they're still even listening to me. Who knows? I might have pissed off all the team there by now. Who knows? Um, you know, I try to be as helpful as I possibly can. Um, Try to give tips where I can anyway. Um, so I don't mean to be insulting if anyone thinks that I am. I apologize. Uh, it's meant to be. It's meant to just share the knowledge. Just pass on what we know to others. There's no sense of malice in what I say or do, so please take it with a grain of salt. That I'm just I'm trying to be as simple as I possibly can. I'm not the best when it comes to everything here, so um, I only know what I've learned over the years, and as much as as I'd love to do more. I'd love to be in the industry more to actually do some kind of work, but that's where I stand right at the moment. You know, Looking for work in this world, but I'll just keep on sending my resumes out for the entry levels and see if I can find something. But that's that's not your concern. You know uh, that's my problem, not you guys'. So um, okay, but with that, I'm going to shut this down. I'm going to save the rest of the tutorial for next week. Um, it's going to be interesting moving to the other tutorials in this, um, because it appears like most of their videos are 5 years old, um, and while they are decent, there's still problems, obviously. Um, so um it'll be interesting to see how the rest of the tutorials are worked out. So um, I'll look forward to that aspect of it. Um, so yeah, I think that's about it there, folks. So thank you for stopping by. Thank you for watching. Um, Feel free to stop on by my YouTube channel. Got links to Twitter, Patreon, Discord, um, and here on Twitch. Uh, so yeah, and then feel free to leave a comment. And I hope to see you guys next week, because I do this every Sunday, 4 to 8 p.m. PST. Uh, and I'm just gonna keep on working through this Unity and get myself knowledgeable enough to where I can probably try to program out something myself and see what I can actually create. I mean, I got plenty of ideas. I have friends that have plenty of ideas, so um, at some point in time, I probably will be trying to create something. Um, uh, I don't know whether or not I can actually do any kind of app or whatnot. Maybe I'll just create something and throw it on like Congregate or something like that. Who knows? Um, we'll see what happens. So, but until then, thank you for watching, there, strangers. I hope to see you next time, and I will catch you next week or tomorrow if you want to see some gaming. So, take care, folks.